All right, next let's add a method to the block class called mindBlock. The mindBlock method will create a block based off of a block input argument that represents the last block for that block, as well as some data to store within the new block itself. So the second argument is going to be data. We're calling this method mindBlock and not createBlock or addBlock to acknowledge the fact that creating a block requires some computational work. You might recall from the blockchain overview at the beginning of this course that creating a block for the blockchain requires computational work in order to allow the blockchain to grow at a reasonable pace. And the analogy for this computational work is mining. So to start this new mindBlock functionality, we're going to add a new section to the block.test.js file's tests called mindBlock. So after the Genesis describe, we're going to have another describe that will be for the mindBlock function. The second argument is going to be our usual callback parameter for these test functions. To mine a block, this function should have a last block and some data to work with. So let's declare those variables first. One, we have the last block, and this can be any block, so we might as well use the Genesis block. Then we have a data field, and this can be anything, and let's call this mined data. Cool. And then we can create a mined block constant to run tests on now. So let's make a mined block constant, and this will be the result of calling block.mindBlock. Notice that this is a static function, just like the Genesis block. And the input to this is going to be an object that consists of one, the last block, as well as the data, which we have fields for in the overall test. So we have the mindBlock function with its object argument that consists of the last block and the data. All right, now we can write relevant tests based off of this mindBlock variable. And let's actually call it mindBlock since it's the result of the mindBlock function. First up, we're going to expect that this returns a block instance. So notice that we have the same exact test as what we have in our Genesis block describe. So let's go ahead and copy that expect statement. So this expect statement expects the Genesis block to be an instance of the block class. And this time we want the mindBlock to be an instance of that block class. The other test of the mindBlock class will be more detailed. We can run assertions based on how this block should be created. To begin, the very first thing that we want to check is that this mindBlock's last hash variable is equal to the last block's hash. So let's say that it sets the last hash variable, and notice that I'm using backticks, which is usually the key next to the one key on the keyboard, because last hash is a keyword. When we want this to be the hash, notice again the use of backticks of the last block. Cool. Then we have our callback as the second parameter again. Nice. And as for the expect statement, we'll expect that the mindBlock.lastHash, so this is the actual value, we want this to be equal to whatever was the hash field of the last block variable. Cool, so this should make sure that the last hash is equal to the hash of the last block. Now, when constructing tests, it can often be confusing which part to place first. Do you place last block in the expect statement or the mindBlock within the toEqual function? After all, switching the two values would create the same exact test. Now, the way to go about this is to put the expected value, meaning the thing that you're checking, within the toEqual function. And then you put the actual value, meaning the part that you want to make sure actually exists, within the expect function. This is a reverse order of most testing structures out there in the programming world. Usually you have the expected value first and then the actual value second, but in Jest, that actual value goes in the expect statement and the expected value goes in the toEqual part. Now we can write a second test for this. Let's say that it sets the data. So this test will be more straightforward. We'll expect the mindBlock's data field to be equal to our data variable. So expect that the actual mindBlock.data is equal to the expected data field that we have at the top. Likewise, we need this mindBlock to have a timestamp. After all, that's part of the block. So we have another it function with its own callback as the second argument. And in this case, we're not concerned that the timestamp is a specific value, but we do want to make sure that it's defined. So let's make sure that the MindBlock.timestamp value is not undefined. We can use an expect statement to check that the MindBlock.timestamp is .not to equal undefined. So this runs an opposite check when you do the .not. So you don't want this to equal undefined, and you do that with the .not chained function right before the to equal within jest. Cool. So go ahead and save this, and then check the overall test suite. And what we see is that we get MindBlock is currently not a function yet. So let's resolve that within block.js. Once you have all of these changes for the MindBlock tests, within block.js, go ahead and declare a static MindBlock function. And recall this takes in an object as the argument that consists of the last block and the data. Cool. And with that, we get more tests that are failing now, but it's a different set of errors. First up, we get a bunch of tests, and it's pretty much every test within the MindBlock scope that is failing. First up, we need this to return a block instance, and we know how to do that since we have an example in the Genesis function. Let's return a new this. Cool, and now we get to a different error. Now it's saying that we haven't really provided values within the instance of this block. So first up, we need a timestamp. Let's make that value date.now. Nice. And then we have a last hash part. So we want this to be the hash of the last block, and we have that last block as the first part of the incoming object. All right, cool. So it has a timestamp, returns a block instance, and it sets the last hash properly. Finally, we want the data to be within the block. So let's add that in, and cool. Our test suite is fully green. Awesome. So we now have this static MindBlock function, which will create a block based on a last block and new data. And this is going to be extremely useful as you develop the blockchain project. But notice that there's one crucial piece missing, and you might have seen it already. Where is the hash of this MindBlock? So to set a proper hash though, we're going to need to create a generic hashing function that can generate a hash value based on unique incoming inputs. So let's tackle that next.